Once we got the matrix A, we need to find out whether A inverse exists or not, because we need to solve it by matrix method. In terms of matrices, if you want to multiply any two matrices, the number of columns and number of rows in the two matrices must be same. Adjoint of a matrix is the transpose of a cofactor matrix. Cofactor is obtained by finding the minors of each element. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are at the last session of the chapter Matrices and Determinants, and in this session we are going to study application problems to commerce. That is, whatever you have done, the matrix method will be in the statement problem. We have to tabulate it in terms of matrix and solve the unknown values. So these type of questions carries 6 marks in your examination under part E. So very important concept under the chapter Matrices and Determinants. First, let us see how to formalize any statement to a matrix. We will take few examples. Later we will move on for the 6 marks type questions. First one, there are two families A and B. There are 2 men, 3 women and 1 child in family A, and 1 man, 1 woman and 2 children in family B. The recommended daily allowances of calories is men is 2400, women 1900 and children 1800. Represent the above data in the matrix form. So now here let matrix X denote the number of person in terms of men, women and children. So here in family A, the first row represents the number of persons in family A. So how many men we have? We have 2 men, 3 women and 1 child. Next, family B represents the second row. So here we have 1 man, 1 woman and 2 children. So this X represents the matrix A of number of persons in a family. Now let Y denotes the number of calories intake by men, women and children. So let me write. So by men, women and children. So that is, for men it is 2400, for women it is 1900 and for children it is 1800. So thus we have represented the given data in the matrix form. Next, the following matrix shows the belonging of 3 friends Amar, Akbar, Anthony. That number of shirts and number of trousers Amar, Akbar, Anthony has 3, 3, 5, 5, 6 and 8. Write down the row matrix which represents the belonging of Anthony. So we need to write 6 shirts and 8 trousers of Anthony in a row matrix. So that is, let me write, denote it with capital letter. So and 6, 8. So thus we have represented the belongings representing Anthony. Next, a man buys 8 kg of apple, 4 kg of banana and 6 kg of oranges. Apple cost 30 per kg, banana cost rupees 50 per kg and oranges cost rupees 24 per kg. Obtain the total cost using matrices. So we know that the total cost is always quantity into price. So to multiply any two matrices there, or to find the cost, what we will do, we will multiply the cost with number of kgs and we will write. In terms of matrices, if you want to multiply any two matrices, the number of columns and number of rows in the two matrices must be same. So for that purpose, I will write one matrix in the form of a row matrix and another in the form of column matrix. So now I have 8 kg of apples, next 4 kg of banana, 6 kg of oranges. This I have represented in a row matrix. Now, apples cost 30 per kg, so I will write it as 30. Next it is banana cost 15. and oranges cost 24 per kg. Price I am writing it in a column matrix. So then only I am able to multiply. So here I have to find the total cost using matrices form. That's why one I'll represent it in row matrix and another I'll represent it in a column matrix. So now let's see the total cost. So 8 into 30. So 8 into 30. Next, plus 4 into 15. Next, plus 6 into 24. So that is first row into first column multiplication. So we will get that. So we can write it in a matrix form. So what is the answer we might get here? So it is 444. So this represents the total cost. So therefore, total cost in terms of rupees is 444. So this is the total cost for the number of apples, bananas and oranges. Next, a salesperson, Samath, has the following record of sales for the month of January, February and March 1996 for 3 products A, B, C. He is paid a commission at fixed rate per unit but at varying rate of products A, B and C. So here we have the months and sales in number of units of the product A, B, C and the commission he will get by selling these products. So in January he sells 9A, 10B, 2C. So that he'll get in terms of rupees, that is 800. February 15A, 5B, 4C, 900 rupees. March 6A, 10B, 3C. So that he'll get 850 rupees. Find the rate of commission payable on A, B and C per unit sold using matrix method. So whatever the tabular information they have given here, we need to convert it in the form of a simultaneous linear equation. Then using matrix method, we need to find out the commission per product A, product B and product C. So we have here complete data. So let us express it in the form of a linear equation. So first I'll write here 9x plus 10y plus 2z is equal to 800. So this is for the month of January. Next for February it is 15, 5, 4, 900. So it is 15x, 5y, 4z is equal to 900. Next we have 6, 10, 3, 850. 6, 10, 3, 850. So this is what I will get. Now let's solve this so that we will find out the XYZ. XYZ represents the commission payable per unit for product A, product B and product C. So here let's write matrix A, that is the coefficients of XYZ, that is 9, 10, 2, 15, 5, 4, 6, 10, 3. So this is our matrix A. Next X, Y, Z. Next matrix B, that is the commission 800, 900, 850. Now once we got the matrix A, we need to find out whether A inverse exists or not, because we need to solve it by matrix method. So writing this, whatever the information they have given carries 1 mark and solution of matrix method contains 5 marks. So totally this is a 6 marks question. Now let's find out determinant A. So determinant A is equal to 9 into 5 3s are 15 minus 10 4s are 40. Next, minus 10. So leave the column, leave the row. 15 3s are 45 minus 6 4s are 24. Next, plus 2 into 15 10s are 150 minus 6 5s are 30. So determinant A is equal to minus 195. So this is not equal to 0. So therefore what we can conclude, A inverse exists. So once you have found A inverse exists. Next, you need to calculate the adjoint of a matrix. So, adjoint of a matrix is the transpose of a cofactor matrix. Cofactor is obtained by finding the minors of each element. So, now let's write adjoint A. So, adjoint A is equal to, for the first one 9, we have here 15 minus 40. So, it is 15 minus 40. Next, for the second one, it is 45 minus 24. Next, for the third one, it is 150 minus 30. Let's look at for the 15 now. So, for 15, it is 10 3s are 30 minus 20. So, 30 minus 20. Next, for 5, it is 9 3s are minus 6 2s are. So, 27 minus 12. Next we have 4. For 4 it is 90 minus 60. Next we have for the last row, that is 6, 40 minus 10. Next for 10 we have 36 minus 30. Next, for the last element, we have 45 minus 150. We should take the transpose of this matrix to get an adjoint A. Now, let us put the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. Now, adjoint A is equal to 15 minus 40, we will get it as minus 25. Next, we have 45 minus 24, minus 21. Next, 150 minus 30, we have 120. Next, 30 minus 20 is 10. Outside, we have minus, so it is minus 10. 27 minus 12, it is 15. Next, 90 minus 60, we have 30, outside you have minus, so it is minus 30. Next we have 40 minus 10, that is 30. 36 minus 30, we have minus 6. Next 45 minus 150, we have minus 105. So let's take the transpose of this matrix. So we get adjoint A is equal to minus 25, minus 10, 30, minus 21, 15, minus 6, 120, minus 30, minus 105. So this is the adjoint of a matrix. Now we need to calculate x, y, z. So for that we have x is equal to A inverse B. So x is equal to adjoint A divided by determinant A into B. Now let me write adjoint A separately. So what is the value of adjoint A? It is minus 195. So minus 1 by 195 into adjoint A is minus 25 minus 10, 30. Next we have minus 21, 15 minus 6. Next 120 minus 30 minus 105. So this is adjoint A, and matrix B is 800, 900, 850. 800, 900, 850. So now let us keep minus 1 by 195 outside. Let's multiply row into column now. Minus 25 into 800. So we have 0, 0, 8 5s are 40, 8 2s are 16, 20. So next we have minus 9,000. Next we have plus 0, 0, 5 3s are 15, 1 carry, 8 3s are 24, 25. So next minus 21 into 800. So 0, 0, 8 1s are 8, 8 2s are 16. Next again, so we have 59s are, that is plus 135, 0, 0. Next, minus we have 0, 6 5s are 30, 3 carry, 6 8s are 48. So we have 51. Next we have 3 zeros, 16, 1 carry, 8, 1 9. So next we have minus 3 9s are 27, 0, 0, 0. Next we have minus 8, 9, 2, 5. So now we have here minus, minus, plus. Adding this and dividing it by minus 195, we will get the solution x. I'll write the matrix x as x, y, z. So adding this and dividing by minus 195. So for the first one, we will get it as 17.95. So next, adding the second row and dividing it by minus 195. So we will get 43.05. Next, adding the third row and dividing it by minus 195, we will get the value as 103.85. So this is the commission you will get per product for product A, product B and product C. So therefore, we can write x is equal to rupees 17.95, y is equal to rupees 43.05, z is equal to rupees 103.85. So this is the commission he'll get per product. Next, a school wants to award its students for the values of punctuality, good behavior, hard work with a total cash award rupees 6,000, 3 times the awards money of hard work added to that given to punctuality amounts to 11,000. The awards money for punctuality and hard work together is double one given for good behavior. Represent the above situation algebraically and also find the award money for each value using matrix method. So they want to award each student for punctuality, good behavior and hard work with a total cash reward of 6,000. So let me take punctuality, good behavior and hard work. So they sum up to rupees 6,000. Next, they have given 3 times the awards money for hard work added to the given punctuality amounts to 11,000. So that means 3 times the hard work added to the punctuality gives rise to the amount 11,000. That means we don't have any good behavior here. So we will write it as 0 into y. Next, they have given the awards money for punctuality and hard work. So punctuality and hard work means x plus z together is double that of good behavior. That is x plus z is equal to 2y. So now this they have given, we have to represent this in a matrix form. So this equation can be written as x minus 2y plus z is equal to 0. Now these are the 3 equations we have. Let us write this in matrix first. So let me write matrix A. First row is 1, 1, 1. Second row is 1, 0, 3. Third row is 1, minus 2, 1. And x, y, z along with B. So B we have 6,000, 11,000 and 0. So now let's solve it. First let us find out determinant A. Determinant A is 1 into 0 plus 6 minus 1, 1 minus 3 plus 1 minus 2 minus 0. So we have here 6 minus 2 minus 1 plus 2 and here minus 2. So determinant A value is 6 which is not equal to 0. Therefore A inverse exists. Once you find A inverse exists, we will write the adjoint of the cofactor matrix. Let us write the adjoint of a cofactor matrix. Adjoint A is equal to, so let us write the matrices here 0 plus 6. Next we have 1 minus 3. Next we have minus 2 minus 0. Now for this one here, we have 1 plus 2. Next we need for 0, so delete the row and column. 1 minus 1 we have. Next for this 3, we have minus 2 minus 1. Next for 1, it is 3 minus 0. Next for minus 2, it is 3 minus 1. Next for 1, it is 0 minus 1. So let us substitute the sign first. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Take the transpose. Now adjoint A is equal to, so first one it is 6, 2. Next we have minus 2. Next minus 3, 0, plus 3. 3, minus 2, minus 1. Take the transpose of this matrix. So adjoint A is equal to 6 minus 3, 3, 2, 0, minus 2, minus 2, 3, minus 1. So now let's take x is equal to A inverse B. X is equal to adjoint A divided by determinant A into B. So let's write determinant A separately, that is 1 by 6. Let us take adjoint A, 6 minus 3, 3. Next 2, 0, minus 2. The last row is minus 2, 3, minus 1. And we have B as 6,000, 11,000 and 0. Let us multiply it. We have 1 by 6. So we have 36,000 minus 33,000 plus 0. Next we have 12,000 plus 0 plus 0. Next we have minus 12,000 plus 33,000 plus 0. So adding it and dividing by 6, we will get x, we will take it as x, y, z. So now 36 minus 33,000 plus 0, that is we will get 3,000 by 6, we will get it as 500. So next we have 12,000 divided by 6, so that is 2,000. So next we have 21,000 divided by 6, so that is 3,500. Now x is for punctuality, that is rupees 500. Y is for good behavior, award 2,000. And Z is for the hard work, that is rupees 3,500. So they will award rupees 500 for punctuality, rupees 2,000 for good behavior and rupees 3,500 for hard work. So the next question is, Transport Corporation operates bus service between two villages. Data regarding the passengers traffic during the first days of the week is given below along with the total for revenue. So day 1, children is 10, senior citizen 10, adult is 20. So total revenue is rupees 90. Day 2, 30 children, 20 senior citizen, 10 adults, 100 revenue. Day 3, 10 children, 20 senior citizen, adult 30, total revenue is rupees 140. Find the bus fare charged per children, per senior citizen, per adult by using the matrix method. So we need to find out the bus fare cost for 1 children, 1 senior citizen, 1 adult in all the 3 days. So first let us express this in a matrix form. So for the first one we have 10, 10, 20 is equal to 90. So therefore it becomes 10, 10, 10 and 90. Next for the second one it is 30, 20, 10, 100. 30, 20, 10, 100. Next 10, 20, 30, 140. 10, 20, 30, 140. So if you write x, y, z here, this completely becomes a simultaneous linear equation which is equal to the constant. So let me write this separately. Let me take this as matrix A, this as matrix X, and this as matrix B. So now let us find the value of x, y, z. X is a bus fare for children, y is for senior citizen, z is for adults. That is for one child, one senior citizen and one adult. Now let's solve this. So here we have 10, 10, 10, 30, 20, 10, 10, 20, 30. So now here we have the tabular. First let us write this in a linear inequalities form. For the first one we have 10, 10, 20, 90. So it becomes 10x plus 10y plus 20z is equal to 90. Next we have 30, 20, 10, 100. So 30x plus 20y plus 10z is equal to 100. Next we have 10, 20, 30, 140. 10, 20, 30, 140. The total revenue cost is for 10 children, 10 senior citizen, 20 adults, you got 90. Similarly, we have for day 2 and day 3. Now, if you calculate X, Y, Z, that shows the individual bus fare for one child, one senior citizen and one adult. We need to calculate X, Y, Z now. So let us divide all the three equations by 10, which is a common factor. So if you divide throughout by 10, here it becomes X plus Y plus 2 is equal to 9. Here 3x plus 2y plus here 2z. Z is equal to 10. And here we have x plus 2y plus 3z is equal to 14. So now let's write this in the matrix. So we have matrix A is equal to 1, 1, 2, 3, 2, 1, 1, 2, 3. Matrix X is X, Y, Z. Matrix B is 9, 10, 14. Now let us calculate the determinant A. So when you calculate the determinant A, the value is here 1 into 2 3s are 6 minus 2. Next minus 1. So 3 3s are 9 minus 1 plus 2. So you have 6 minus 2. On solving this, we get determinant A is equal to 4, which is not equal to 0. Therefore, A inverse exists. So once A inverse exists, we need to calculate the adjoint A. So therefore, adjoint A is equal to, so write the cofactors of all. For the first tree, we have here 6 minus 2, 9 minus 1 and 6 minus 2. Let's see for the 3. Now, for 3, it is 3 minus 4. Next, for this 2, it is 3 minus 2. Next, for 1, it is 2 minus 1. Next, for 1, it is 1 minus 4. Next, for 2, it is 1 minus 6. Next, for the last 3, we have 2 minus 3. So, transpose of this matrix, put the sign plus, minus, plus, minus, plus, minus, plus, minus, plus. Now, let's write adjoint A. That is 4, minus 8, 4, minus 1, plus 1, it becomes 3 minus 4, minus 1, 3 minus 2, 1, 2 minus 1, 1, so which is minus 1. Next we have 1 minus 4, minus 3, 1 minus 6, minus 5, minus 5 minus outside plus 5, 2 minus 3 is minus 1, so it is minus 1. Take the transpose of it, we have adjoint A is equal to 4, 1, minus 3, minus 8, 1, 5. Next, last we have 4, minus 1, minus 1. Now, let's take the matrix X. that is equal to A inverse into B. So now X is equal to A inverse is adjoint A divided by determinant A into B. So adjoint A is what we got as 4. So we write it as 1 divided by 4, adjoint A as 4, 1 minus 3. Next, minus 8, 1, 5. Next, 4 minus 1, minus 1. And matrix B, we have 9, 10, 14. So X is equal to 1 by 4. Now let us multiply. So we have 36 plus 10 minus 42. Next, minus 72 plus 10 plus 70. Next we have 36 minus 10 minus 14. So on solving this, we take X as X, Y, Z. So here we get 36, 46 minus 42, 4. Minus 72 plus 10 plus 70, we will get it as 8. 36 minus 10 minus 14, we will get it as 12. And here we have 1 by 4 outside. So dividing this, we get X, Y, Z is equal to 1, 2, 3. So therefore, X is equal to rupee 1, Y is equal to rupee 2, and Z is equal to rupee 3. So this is the cost of bus fare per children, per senior citizen and per adult. So transforming the data into matrix and finding the solution of XYZ for matrix method is one very important question which is for 6 marks in your examination. This is all about the chapter determinants. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.